start our adventure with the Algebra 2 F word. We're going to rewind for a moment. Here, it says multiplying a polynomial by a polynomial, FOIL. Okay, so what's this got to do with factoring? You'll see in a moment. But just a reminder, when you're foiling, you're multiplying your first terms together. X times x is x squared. So that would give us 2x squared. We should have written a little lower. And then our outer terms, x times negative 4 is negative 4x. Our inside terms, 3 times 2x is 6x. And our last, 3 times negative 4 is 12. We combine our like terms, which typically are going to be found right here in the middle. Not opposites to do them, just combining. And we're set. But probably, gosh, is there even a no, there's not a probably about it. The most missed quiz question that you will see on the next quiz is something that looks something like this. Because it's very easy to want to just say, well, what? You distribute the squared, and it's x squared plus 25. That's close. That's close. Here's why normally when that comes up, I tell people to consider writing it out, because squared means there's two of them. And then you're not going to get yourself into that trouble. In first times first, x squared, okay. And some of you are like, well, Artie, and 5 times 5, that's 25. Well, that's true. But here's the problem. You still have an outer and an inner. So, either you should write it out like we did here. Otherwise, there's a pattern to this, just as a reference. If you do the pattern, you square the first term. You multiply the two terms in the parentheses together. If the sign was a minus, you'd pay attention to that. If I multiply them together, that'd be 5x, and you double it is 10x. And then you can do your last term. So if you're a pattern person, that works. If not, just write it out when you run into that situation to keep yourself out of a little trouble. So what does this mean? Okay, factoring is what we just did backwards. We're going from this back to the original factored form, the form in parentheses. So there's several different ways to factor depending on what the problem looks like. We're going to start basic today and build. So factoring, no coefficient in front of the x squared. I mean, it's 1, but we don't see 1. It's guess and check. So here's what we're going to do. We need to find a pair of numbers that multiply to get the number on the outside and add to get the number on the inside. So here's a couple of hints to help you out with these. Okay, here's the first hint. When you look at your multiply number, you're going to want to look at that first. If it's negative, that tells you a story about the signs that are going to be in here. The only way to get a negative product is to have one positive and one negative number. Might not even be a bad idea to put. So if I get positive and negative, that's going to be my negative multiply here. So now, I got to think for a moment here of numbers that multiply to 28, but since the signs are different, they're 12 apart from each other. So for some of you that are like, oh boy, me and my multiplication facts, we got to come back here to this again. Maybe. Which one of those pairs is 12 apart? 2 and 14. Okay, so does it matter where I put the 2 and the 14? Yes. Mm-hmm. Yep. That's the sign of the bigger number. 14 and 2. So if I were to FOIL this out now, x squared minus 2x plus 14x, those are the ones you're looking at, really, or those two pair, to see if you get what's in the middle. And 14 times negative 2 is negative 28. So if you're a check type person, you want to make sure, that's the way to make sure. Now, what if? Lots of what ifs. Okay, the multiply number is positive. But if the multiply number is positive, both numbers could be positive, both numbers could be negative, because negative times negative is positive. That's what the middle sign tells you this time. Okay, they're both going to be negative. Two numbers that multiply to 80 and add up to 18, because the signs are the same. Now, if you're not sure, you're like, Hardy, how am I supposed to know all that? Off the top of my head? Okay. If you're not sure, my suggestion is to start small and start dividing numbers in that you're pretty sure are going to go in until you find the pair that are 18 apart. I mean, it add up to 18. We're close. Oh, we're getting closer. Hardy, that wasn't even there. 8 and 10 add up to 18. If you've got to go that route or make yourself a little multiplication factor tree, do it. As you do it more, you're going to get faster. I know sometimes in Algebra 1 they give you like multiplication charts and things. I'll do charts for some stuff. That's just not one of them. So it'll get you better as you get faster with your multiplication facts. But again, the calculator will be there as an option. Well, that's when there's no number in front. That's always the multiply. That's always the add. Now, here comes the major twist of the day. What happens if there's a number in front of x squared? Is it still just multiply and add? It might not be. It might not. It depends on how we're going to tackle it. If you do it, I'm going to call it the preferred way, but I'm not going to force you to go this route, is to look and start going, okay, you know, what can I multiply together to get 2? Well, in this case, 2 and 1. I mean, it's my only option. And then you start thinking about all the numbers that can multiply to 10, and you just start in your head or physically like this, start writing them in until you find the right pair that goes together that you can get to the number in the middle. So let me kind of explain here a little bit. Let me cover this up for a sec. Or actually, no, let's just do it on this one. So I look and I'm like, okay, there's a 3 in front. So let's see here. There's only one way I can multiply to get 3. So that's 3 and 1. Okay. Now, I can figure out the signs from here. If you multiply to get a positive, the signs have to be the same, like we said up above. That sign in the middle still will tell me which sign it's going to be. So they're both minus. Now the game, though, becomes, okay, there's my factors of 10. Pencils might come in handy here, or if you just want to do it in your head, you can. You're like, all right, 3 times 1 is 3. 1 times 10 is 10. Is 3 and 10 get me to 17? No. Reverse them. 3 times 10 is 30. 1 times 1 is 1. Does 30 and 1 get me to 17? No. 6 and 5 get me to 17? No. 15 and 2 get me to 17. So I need the 3 to go with the 5. And I need the 1 to go with the 2. There's negative 2x. There's negative 15x. That adds up to negative 17. Negative 2 times negative 5 is 10. 3 times 1 is 3. Okay. That one worked. It's either physically write it out or in your brain, guess and check. That, in the long run, will be the fastest way you can do these if you got your multiplication terms down. Now, if you don't, or if you would give anything for these to be back up like the ones in the section before, you have an option. I'll show it to you. You can do it. It just takes longer. So, if you're a guess and checker, guess and check me on 6. If you're looking for a possible option, okay, here we go. The option is something called slide and divide. Here's what we're going to do. Oh, just watch and be amazed. Watch and be amazed. So the slide means we're going to multiply your lead coefficient to this end term. Okay, so 2 times 18 is 36. All of a sudden, it looks like the problem's in 3 and 4. Which isn't a bad thing. So I'm like, okay, so do I get to do it like number 3 and number 4? I do. I'm multiplying to negative 36. Okay, cool. 1 plus 1 minus. The add number is the bigger one, so I know the negative will be larger. So I need 2 numbers to multiply to 36 that are 9 apart because they're different signs. Let's see here. 36. 36, 2 and 18, 3 and 12, 4 and 9. Any of those 9 apart? 3 and 12. So you're like, I'm done. No, here. Slide and divide. I did the slide. One last step. I got to do the divide part. Here's how it works. You remember we multiplied that 2 down here? We're going to divide my binomial terms by it. If it goes in nice, like 12 divided by 2 goes in nice, we just divide it. That's cool. If it goes in and gives you a decimal, once that fraction is completely simplified, 3/2 is, you can just tuck the 2 back in front, and you're done. 3 times x is 3x. Negative 6 times 2 is negative 12. Negative 12 plus 3 is negative 9. I'm in the same place. Sometimes guess and check has its place because you're going to get really large numbers sometimes, and you may be going through 5, 6 different pairs you're trying to do. Sometimes that'll be faster. I'm going to admit it. But again, I get in trouble every year when I show that because I'm like, people need options. So we got to work it that way. Oh, dear. Last ones. Most challenging, no prime numbers. So now, not only do we have to play with these numbers, we're going to play with these too. So let's see here. We got 1 and 8. We got 2 and 4 there. For 9, I got 1 and 9. I got 3 and 3. Let's see here. One thing I know, everything is plus, so hey, we got to find the positives when we can get them. And now, again, it's just a game of, can I find the pairs that are going to get me to 18? So I'm like, all right, 1 and 72, no. Not 8 and 9. Ooh, that's close, but no. 3 and 24, no. And that went both ways, so that didn't work. 2 and 36, no. 18 and 4, no. Dang. 6 and 12, ooh. 6 and 12, that gets me to 18. So 2x and 4x and 3 and 3. Let's see. 12x in the middle, 6x on the edge. There's 18, 9, 8. Yep, that's the one. So I will, if this is going well, I'll see lots of fingers going around with these or the head working, trying to think through what the possible combos are. But again, that's what you're looking at. So now, on 8, I'm going to do it both ways, just so you can see again and kind of decide for yourself what you think at the start here is going to be best for you. Because sometimes, again, these can get a little bit crazy. So just looking at my pairs here, we know one's positive and one's negative. That's going to be interesting. And so whatever we get for our combos, we need to put them together and end up at 9. So I always look at that as 9 apart. This is going to be ridiculous. 1 and way too many, so it's not that. 14 and 18? Nope. 2 and a whole lot? No. 36 and 7? No. Okay, that not helpful. 2 and a whole lot? Nope. 28 and 9? Nope. 4 and 63? Nope. 14 and 18? Nope. Man, I'm a bad picker. 3 and a whole lot? No. 42 and 6. Really? The last one again? Yep. 6 and 42? No. 21 and 12. Okay. 21 and 12, if I subtract them, get me to 9. So I just got to figure out the signs now. So 3x and 2x. I want the 7 to go with the 3 and the 6 to go with the, oops. Six to go with the 2. Negative 21 and positive 12. That's negative. Okay, that didn't work. We got to switch the signs. Positive 21, negative 12. That's a lot of guess and check. Like, I didn't do that on purpose. It took me that long to get to the 6th one. If you want a definitive, this ain't going to be pretty, but I'm going to show you anyway. Because I like to get options out there. Sometimes the struggle, we just got to deal with it. Ooh, this is going to be a little crazy, though. Okay. You're like, yeah, party, nope, I'm out on this one. Oh, give me a minute, though. I don't think some of you will be. Multiplies to a negative, one of each side. All I have to do now, I don't have to play the game with both. I just have to play the game with, I got to keep messing with these until I find a pair that are 9 apart, and I'm getting there. Now, am I having to do a lot of button pressing? Yeah, but I know how much some of you can play on phones and stuff. You darn well know you can do this fast. 28 and 9, I'm getting close. 12 and 21. 12 and 21 get me to 9 in the middle. The only thing I got to remember now is I'm not done. I've got the divide part, and here's the thing that people forget on slide and divide. Your fraction has to be simplified before you can do the last step. So if it's bigger numbers especially, you've got to make sure you get here before you tuck that denominator back in. Whoop. Front. Same thing. It's totally your call. On problems like that, none of them are pretty. But if you get stuck one way, you're always going to have an alternative that you can go to. Most of the problems we do will be more like number 7, number 5, number 4. Not this big craziness, but it does happen, just to kind of put it out there. Are, are the brains swimming on Monday morning yet? We're almost there. I saved the easy stuff for last on this because after that, people's brains are like blown. They're like, what the? Sometimes we might just get to take out something in common. That's always nice. Largest number that goes into 4 and 8 would be 4. They both have a t. You always take out the largest number and the smallest exponent. I get people doing the opposite. I'm like, nope, it's got to be smaller so we can get those in. 4 is the largest number that goes into both. Once I get here, 8 divided by 4 is 2. 2 minus 1 is 1. Remember, with exponents, we're just saying I've already got 1. How many do I need to get to 2? 4 times what is negative 4? Negative 1. And I already have 1t. Don't take another. Sometimes that's all you're going to be able to do. We hope for lots of those. Oh, I got to do slide and divider, the big one. Do you? Anything divide into 3 and 6 and 24, if it does, get it out. That will make your life easier on all factoring problems. Because now that I took that 3 out, now it's just a regular multiply and add. Multiply to a negative. Got to be one of each. Add to a positive. The positive is going to be the bigger number. Multiplies to 8, 2 apart. 4 and 2. And if you're ever in doubt, just do the outer and the inners like I've done on a few of these to see if you get the middle term. Okay, positive 4x, negative 2x. Yeah, that adds up to 2x. That 3's got to stay, though. It doesn't disappear. It just keeps working. So one last one to throw your way, and maybe I'll throw this at you right away. Well, we'll see. Difference of 2 squares. If you see numbers that are perfect squares, or variables that you could multiply by themselves to get perfect squares, we can actually factor these. I like to draw in the little, what do I square to get it part in there, because then when you go to do the pattern, it's easier. So we're going to do first plus second, and then we're going to do first minus second, which is why I like to draw these out. But that's all you have to do. You don't have to go any further. That one's set, as long as you have one of each sign. Now, some of you may look at this and go, wait a minute, those aren't perfect squares. 5 isn't, neither is 20. That's true. But once I take the 5 out, because they have the 5 in common, now what's left? What do I square to get x squared? X. What do I square to get 4? 2. The 5 is still there. There's my 2 terms. First plus second. First minus second. And I'll be honest with you on the perfect square trinomial. I have a feeling most of you are just going to factor these normal like we did on the front. But if you happen to notice, if you have a trinomial and your first and your last terms are both perfect squares like we have here, and then you just keep the sign in the middle. Otherwise, if you normal factor that and get 3y plus 4, 3y plus 4, that's fine. It's not wrong. It's not bad. This is just one of those things, if you happen to see it, if you see that perfect square in there, it's just a way to speed things up. So that's my biggest thing to tell you with these. Your first job whenever you factor is to ask yourself, is there something in common that I can get out to make these numbers smaller and make this easier? If the answer is yes, it behooves you to go ahead and do that. Because that's going to be some big old numbers that you're trying to break down if you don't. Now we even get the benefit of it just being x squared. I know because of my multiply number, it's one of each sign. Two numbers that multiply to 70 that are 3 apart, I can handle this one. 10 and 7. And I'm set. Don't let fourths mess with you. We're going to treat them just like they're x squared. You're like, but they're not x squared. Well, yes and no. M times m is m squared. M squared times m squared, 2 times 2, or 2 plus 2 in this case, would be 4. So don't let things mess you up just because they look a little different. The pattern is still the same as it is for difference of squares right here. First plus second. First minus second. And 17, I'm just going to say it, is your choice of slide and divide or figuring out what your pairs are going to be. I'm perfectly willing to work with some more of you on slide and divide if you want to go that route. 5 and 4 going to work for me? Ooh, it is. -4, -15. There's that number in the middle I wanted. So this is a day one hodgepodge of a lot of different factoring formats. And again, that's why we hang out for a couple of days with the factoring stuff here at the start, and then we keep seeing it as we go. Critical, people, I can't say this enough, critical as we work through this stuff that you are practicing. I'm not even going to say on this stuff, well, just do that. No, you need the practice at this point. So I would try to bust through all of these. If you just get to the odds today, okay. But I'm just saying, before the quiz, you're going to want to have checked all of these out. But always ask yourself the question before you start. Is there anything in common with all of your terms? Can I take out a number? Can I take out a variable? Maybe I can take out both. Maybe I can take out none. I don't know. But be always looking to check and see if you can make something easier with those. And I'll even check at the beginning of class tomorrow to see if there's a couple of these we need to chat about as we're working